Foreign, a nation known for its historical passivity to wars, has stunned the world with this groundbreaking development. It's left us all wondering what might be brewing beneath the surface. In an even more unexpected twist, the country has forged alliances beyond a traditional partnership with the United States to achieve its Air Force goals. They've joined forces with other nations to create a powerful sixth-generation stealth fighter, and the Godzilla F-X may change the meaning of warfare on a global scale. The growing regional tensions and emerging threats have likely played a significant role in Japan's new decision to bolster its defense capabilities. With potential challenges on the horizon, it has become increasingly crucial for the country to adapt and prepare for an ever-evolving global landscape. Join us as we explore the features and capabilities of Japan's formidable powerhouse, the Godzilla F-X, that shocked the world. Since World War II, Japan has been hesitant to build up its military, especially its Air Force, which is now outdated compared to modern standards. The trauma of the war, alongside the devastation it brought to Japan and its people, left a deep aversion to militarism. The memories of Hiroshima and Nagasaki are a haunting reminder of the cost of war. Also, Japan's post-war constitution, shaped under U.S. influence, committed the country to a pacifist stance. Article 9 of the Constitution renounced Japan's right to wage war or maintain military forces for offensive purposes, restricting its military capabilities strictly to self-defense. Japan entered into a security alliance with the United States. 2. This alliance involved the presence of U.S. military forces, including air units stationed in Japan. It provided a security umbrella under which Japan could focus on rebuilding its economy and infrastructure, relying on the U.S. for defense. The immediate post-war era demanded substantial investments in economic recovery and development, leaving limited resources for military expansion, so this was an excellent deal for Japan at the time. The country's relations with neighboring countries, especially China and South Korea, have at times been tense, and their cautious approach to military buildup was partly driven by a desire to avoid appearing aggressive in a region with complex historical and political tensions. Unfortunately, this approach might no longer be enough. China's remarkable economic and military growth has taken on a more confrontational tone toward Japan, leveraging its economic clout. China has imposed trade restrictions and boycotts on Japan due to Japan's support for Taiwan and its defense cooperation with the United States. But that's not where it ends. China has taken a more covert approach as well, resorting to cyber attacks and espionage. They've been hacking into Japan's government and corporate networks, seeking to pilfer defense and technology secrets. And of course, there's a military element to this confrontation. 2. China has upped the ante by increasing naval and air activities near Japanese territory. Live-fire drills are a regular occurrence, and they've even launched ballistic missiles close to Japan's ally, Taiwan. Given all these provocations and more, Japan has to modernize its aircraft to avoid relying only on foreign allies, especially since China and Russia are introducing advanced fighter planes. Initially, the country considered purchasing the Lockheed Martin F-22 Raptors, capable of rivaling Russian and Chinese counterparts. However, the U.S. banned the export of these fighters to protect its technology, leaving Japan with no options. As a result, the Japanese military decided to embark on an unprecedented journey by developing its very own sixth fifth-generation warplane. While this ambitious endeavor faces numerous obstacles, its potential success could provide Japan with a cutting-edge warplane and a prominent place in the global arms industry. Between 2009 and 2010, the Japanese Ministry of Defense conducted a thorough study of combat aircraft technology, leading to the concept of a sixth-generation fighter named the I-3 fighter, which stands for Informed, Intelligent, Instantaneous. This next-generation fighter would feature advanced radar systems, data processing through flyby optics, stealth technology, gallium nitride semiconductors for enhanced radar performance, and a more powerful engine. The Ministry of Defense developed a unique demonstrator platform known as the Mitsubishi X2 Shinshin to test and refine these technical requirements. The experimental prototype allows engineers to experiment with various technologies, providing valuable insights into the development of their next-generation fighters. Structurally, the X2 follows a modern fifth-generation fighter design, similar to the Lockheed F-22 Raptor. Its dimensions are close to the Swedish Saab JAS-39 Gripen, with a length of about 14 meters and a 9-meter wingspan. It weighs nearly 13 tons and boasts powerful turbojet engines with three-dimensional thrust vectoring systems, offering exceptional maneuverability and supersonic cruising capability. One of the aircraft's most intriguing features is its experimental object remote control system called flyby optics. This system replaces most traditional cables with optical fiber, increasing data transmission capacity and electromagnetic interference resistance. The entire A-frame is embedded with micro-antennas that analyze radar signals, allowing the X-2 to effectively counteract and suppress radar detection. Its prototype was a success, and many of its showcase systems will likely find their place in the sixth-generation fighter. This twin-engine, fixed-wing aircraft had a sleek design with a height of 4.51 meters. Its cropped delta wings and advanced root extensions enabled it to safely maintain a high angle of attack. The two vertical stabilizers on the trailing edges also improved aerodynamics and stealth features. The single-pilot fighter sported a retractable tricycle landing gear configuration, aerodynamic control surfaces, and two rectangular intakes flanking the cockpit. Furthermore, its S-duct design boosted its aerodynamic efficiency. Following insights gained from this Shinshin X2, the Japanese Ministry of Defense initiated the early development of the Mitsubishi FX in 2020. This twin-engine stealth fighter, designed for air superiority, is set to be notably larger than the F-22, earning it the nickname Godzilla. This increased size will grant it exceptional range and a substantial ordnance capacity. The focus is also on unparalleled network capabilities and the ability to carry more missiles than the F-35. Various exterior designs have been proposed and tested using 3D modeling and specialized virtual simulation software. The design priorities include speed, agility, and stealth to enhance its flexibility and reduce weight. The FX will replace conventional hydraulic systems with electric actuators and use advanced adhesive molding instead of traditional fasteners. Powering this fighter will be two XF9 engines, providing over 20 tons of thrust. These engines feature three-dimensional thrust vector nozzles for maneuverability and improved stealth. Regarding armament, the FX will be equipped with an array of sensors to engage enemy stealth aircraft, including an active electronically scanned array radar, a passive radio frequency sensor, and an infrared camera. These sensors will employ gallium nitride technology to enhance their performance against low radar cross-section targets. Additionally, it will have an RF self-defense system that can instantly disrupt radio waves globally to thwart incoming projectiles. It will also feature a helmet-mounted display with a wide field of vision, binocular capabilities, multicolored display, voice recognition, and 3D sound. The FX stealth features include serpentine air ducts, an internal weapons bay, electromagnetic wave absorbers, and metamaterials. These attributes dramatically reduce its radar cross-section. Moreover, a plasma stealth antenna system will deflect radio waves, creating temporary plasma bursts to deter incoming radio waves. Beyond conventional armaments, the FX will be armed with a microwave cannon to disrupt incoming missiles. It will also have the ability to deploy combat support unmanned aircraft drones, serving as loyal wingmen to the fighter. These drones will aid in target identification, munition deployment, and deflecting incoming missiles. If the FX Godzilla lives up to even a fraction of its potential, it could provide the Japanese armed forces with a formidable warplane surpassing anything in today's skies. Furthermore, it has a potential to propel Japan into the global weapons development market, solidifying its position as a military manufacturing powerhouse. Another thing the FX Godzilla will be doing is replacing Japan's current F-2 jets. The F-2, a pivotal asset of the Japan Air Self-Defense Force, JASDF, for short, has quite a story behind its development. It even triggered some international crises along the way. While it might look like an F-16 on steroids at first glance, a closer look reveals it's a different kind of fighter. The JASDF, the sole user of this aircraft, dubs it a fourth, fifth-generation fighter, which is a pretty accurate label to some extent. The Japan Air Self-Defense Force had the concept of a support fighter developed in 1977. The role of support fighter encompassed anti-ship attacks, ground assaults, close air support, and defense against airborne threats. It differed from a multi-role fighter as its primary focus was in air-to-air combat. The Japanese Air Force initially relied on F-86FS for these support fighter duties, which Mitsubishi F-1s later replaced. However, After introducing the F-1 in 1978, Japan initiated a study for its successor due to the F-1's limited 3,500-hour lifespan. In 1982, Japan greenlit the development of the next support fighter. This new aircraft had to feature a fly-by-wire flight control system, all-weather capability, advanced electronic warfare capabilities, and improved air-to-air combat capability. The envisioned aircraft would carry 4 anti-ship missiles and A-2M missiles while boasting a combat radius exceeding 830 kilometers. By 1985, it became apparent that domestic development of the aircraft was possible except for the engine. This prompted Mitsubishi and Kawasaki, 2 Japanese aircraft companies, to embark on their indigenous programs. Mitsubishi was confident due to its prior experience developing the T-2 CCV research aircraft and possessing a domestic fly-by-wire flight control system, so they set to work on the JF-210. Concurrently, Kawasaki designed an aircraft with silhouette akin to the FR-A-18 Hornet. However, the level of air-to-air combat capability remained uncertain, leading to evolving specifications and design changes that increased confusion and cost during the design process. Ultimately, Japan realized that the research and development costs for a domestic support fighter would be exorbitant. Direct procurement from abroad was also impractical since no available fighter met their Air Force requirements at the time. Therefore, Japan decided on a joint development program, which was more economically viable. In 1986, U.S. companies General Dynamics and McDonnell Douglas offered collaborative development based on the F-16 and FO-18, respectively. The Europeans presented a capacity-enhancing proposal centered around the Tornado. However, the technology transfer offers and industrial cooperation levels fell short of Japan's expectations. By 1987, the Tornado was removed from consideration. McDonnell Douglas proposed a new aircraft based on the F-15, which Japan already used. After meticulous evaluation, Japan selected the F-16 as a base aircraft, specifically an enhanced F-16 variant that General Dynamics had been working on as a low-cost alternative for the Advanced Tactical Fighter program. Although initial hurdles were cleared, new challenges emerged in the early 1980s. The Reagan administration aimed to bolster the military capabilities of the Western Bloc. Consequently, the U.S. Department of Defense supported Japan's new combat aircraft program, promoting cooperation and technology transfer. However, the U.S. Department of Commerce had contentious dealings with Japan. Historically, the trade balance had shifted against the USA for an extended period. The Commerce Department preferred pressuring Japan to directly purchase U.S. weapon systems. Additionally, technology transfer raised concerns that Japanese aviation companies could become competitors to U.S. firms. Moreover, Japan had a reputation for leaking critical industrial secrets to the USSR. Nonetheless, in 1988, the USA and Japan reached an agreement on the joint development program, although detailed discussions continued for another year. In 1989, the U.S. Congress approved the deal with certain restrictions. These limitations included constraints on providing the F-16 source code, maximizing work shares for U.S. companies during production, and Japan offering critical technology transfers to the USA. The manufacturing of the F-2 was shared between Japan and the USA with a 60-40 ratio. Mitsubishi acted as a primary contractor in Japan, with several other Japanese companies like Kawasaki and Fuji serving as subcontractors. The engine were produced under license by IHI. In the USA, General Dynamics was a leading partner in the program, even though Lockheed Martin took over the aircraft production facilities in Fort Worth in 1993. The F-2 conducted its maiden flight on October 7, 1995. Minor issues cropped up during test flights, including microscopic cracks in the main wing structure, causing delays. After resolving these problems, the F-2 was officially introduced into the JASDF service in 2000. Initially, Japan had plans to acquire 141 F-2s, but due to high unit costs, that number was later reduced to 94. The aircraft may resemble the F-16 but features a host of detailed differences. As mentioned, its fuselage is 0.5 meters longer than the F-16 Block 40 variant, and its wings are 25% larger, allowing it to carry more substantial ordnance on its underwing pylons while enhancing maneuverability. Mitsubishi also redesigned the vertical stabilizer to improve flight performance, especially for anti-ship missile operations. The air intake changed to accommodate a larger nose radome housing a locally developed radar, the JRAPG-1. This radar makes the F-2 the first production combat aircraft with an active electronically scanned array radar, granting it exceptional anti-ship, ground attack, and interception capabilities. To enhance stealth, the wings, horizontal tail fin, rudder, and landing gear doors are constructed from carbon fiber reinforced composite material. The rear fuselage and tail unit are made of titanium. Additionally, Mitsubishi employed its RAN radar-absorbent material for the nose, wing leading edges, and engine intakes. In contrast to the F-16's two-piece cockpit canopy, the F-2 boasts a three-piece cockpit canopy, providing increased durability against bird strikes. This feature renders the aircraft well-suited for low-altitude ground and maritime strike missions. Unlike U.S. Air Force F-16s, the F-2 features a brake chute. It's however apparent that Japan looks up to the U.S. for some design and function inspiration. They've also purchased some F-35s to use alongside the Godzilla F-X once it's ready. There may even be a new development with the F-X fighter because the UK and Italy have issued a joint statement with Japan regarding their cooperation in developing the next-generation fighter aircraft together. The program builds upon the significant progress already achieved in the UK. Companies like BAE Systems, Leonardo UK, MBDA UK, Rolls-Royce, and the UK Ministry of Defence have been working together since 2018 as Team Tempest to research, evaluate, and develop various capabilities for future combat air systems. Team Tempest is ensuring the security of the United Kingdom both today and for future generations is a top priority for the government. This necessitates staying at the forefront of defence technology to outpace and outmaneuver potential threats. The international partnership announced with Italy and Japan aims to achieve precisely that, emphasizing the interconnected security of the Euro-Atlantic and Indo-Pacific regions. Work on the joint engine demonstrator is slated to begin in 2024, with the UK investing an initial £30 million in planning, digital design, and innovative manufacturing developments. An additional £200 million of UK funding will go towards developing a full-scale demonstrator power system, supporting numerous highly skilled jobs, including those at Rolls-Royce's Filton facility in Bristol. Together, these countries will work on creating a multi-role sensor that enhances future warplanes' intelligence, surveillance, and reconnaissance capabilities. Japan, already involved in assisting Rolls-Royce with propulsion system demonstrator, will provide valuable technological advancements for the new British warplane. It will be capable of producing and storing electrical power generated by gas turbine engines, employing a thermal control system to enhance performance and reduce the Tempest heat signature. Japan's entry into this collaboration is a significant development. The partnership between the UK and Japan will also focus on the development of the Jaguar sensor system, designed to detect threats from air, land, and sea and locate targets quickly and accurately. This joint effort is set to continue over the next 5 years. The UK's Defence Secretary, Ben Wallace, emphasized the importance of international collaboration in such an ambitious project, leveraging the technological and industrial strengths of both countries. They will explore a wide-ranging partnership encompassing next-generation combat air technologies, 3D printing, and advanced radar systems. The first flight of the Tempest is anticipated in 2035, and it will replace the Eurofighter Typhoon in Italy and the UK as well as the Saab Gripen in Sweden. The manufacturing process is expected to incorporate 3D printing, and Leonardo is working on a multifunction radio frequency system for the Tempest. This system, which uses a network of smaller antennas and miniaturized receivers, reimagines radar technology, collecting vast amounts of data from the skies and the ground. Like other sixth-generation aircraft, the Tempest will likely utilize artificial intelligence software for autonomous drone operations following the Loyal Wingman concept. The cockpit will incorporate augmented reality technology, making it an ambitious and technologically advanced project. Speed and international cooperation will be crucial for the Tempest project as it aims to stay competitive with China and Russia, both of which have made progress on their own next-generation fighters. It's unclear how this collaboration might impact Japan's Godzilla F-X project, as they are actively assisting the UK and Italy with the Tempest. Some speculate that these three nations could eventually join forces to create a completely new aircraft that leverage the strengths of their respective fighter jets. Regardless of the plan, the United States supports Japan's security and defense cooperation with like-minded allies and partners. If Taiwan were to be captured, the islands at the southwestern tip of Japan might become hard to defend. China could then tighten control over Japan's crucial trade routes, escalate tensions around the disputed Senkaku Islands, and exert pressure on its long-standing rival. To prevent this, Japan needs a united effort to prevent China from invading. Additionally, addressing the threat posed by North Korea is imperative. While it may surprise some, we can all admit that there is no better time for Japan to develop its military strength than now. Thanks for watching. While you're still here, click on the link appearing on your screen to check out another of our videos. See you there.